Determine all intervals of concave up or concave down and determine the coordinates of all inflection points, including cliffs, for the function f of x equals x to the fourth minus 6x squared minus 8x plus 3. The first thing to do is find the domain. F of x equals x to the fourth minus 6x squared minus 8x plus 3, which is a polynomial, and a polynomial has a domain that is all real numbers, or negative infinity to positive infinity. The next thing to do is find all candidate numbers. We will need the second derivative for this. We will start with the first derivative. F prime of x equals, the first term is power rule, bring down the power, subtract 1 from it. Second term is power rule, bring down the power, multiply with the negative 6, subtract 1 from it. Third term is a constant times x. The derivative is the constant. Fourth term is a constant with no x. Derivative is a 0. We can now find the second derivative. First term is power rule, bring down the power, multiply with the 4, subtract 1 from it. Second term is a constant times x, derivative is the constant. Third term is a constant with no x, derivative is a 0. We will want to fully factor the second derivative. There is a common factor of 12. Factoring it out will leave behind x squared minus 1, which is a difference of squares, and so can further factor into x plus 1 and x minus 1. We can now set the numerator equal to 0, and the denominator, if there is one, also equal to 0, and solve for all x's. Because of the x plus 1 factor, x equals negative 1, and because of the x minus 1 factor, x equals positive 1. We will now check to see which of these are in the domain. The domain is all real numbers. X equals negative 1 is a real number. X equals positive 1 is a real number. We keep both of them. They are both candidate numbers to be a possible inflection point. We can now draw a domain line, a line representing the domain. It has no left end because it begins at negative infinity, and it has no right end because it ends at positive infinity. We can put all candidate numbers on here. In order, we have a negative 1, and we have a positive 1. This splits the domain interval into 3 separate intervals. We can pick a test value in each of the intervals. The first interval is negative infinity to negative 1. We can pick a test value of negative 10. The next interval is negative 1 to positive 1. We can pick a test value of 0. And then we have the interval from 1 to positive infinity. We can pick a test value of positive 10. We can now test the concavity in each of these intervals by plugging the test values into the second derivative. We don't care about the value of the second derivative, just whether it is positive or negative. So the best place to plug in is the fully factored version. Plugging a negative 10 in, negative 10 plus 1 is a negative. Negative 10 minus 1 is also a negative. Negative times negative is a positive, times the positive 12 is still positive. We have a positive second derivative, which corresponds to concave up. Plug in the test value of 0 into the fully factored version of the second derivative. 0 plus 1 is positive, 0 minus 1 is negative. Positive times negative is negative. Times the positive 12 is still negative. We have a negative second derivative. This corresponds to a concave down. We can now plug a positive 10 test value into the fully factored version of the second derivative. 10 plus 1 is positive. 10 minus 1 is positive. Positive times positive is positive. Times a positive 12 is still positive. We have a positive second derivative, which corresponds to concave up. So we have concave up happening on the interval negative infinity to negative 1, and union, because it's happening again, from positive 1 to positive infinity. We have concave down happening on the interval from negative 1 to positive 1. Write as a candidate number of x equals negative 1 we have the concavity changing from concave up to concave down. That will make x equals -1 an inflection point. So we have an x-coordinate of -1, and there will be some corresponding y-coordinate, which can be found by plugging the -1 back into the original function. So y equals f of -1, which is -1 to the 4th power minus 6 times -1 squared minus 8 times the -1 plus 3. -1 to the 4th power is a positive 1. Minus 6 times -1 squared is a positive 1. A minus 8 times a -1 is a positive 8. And then plus 3. 1 minus 6 times 1 is a minus 6. Plus 8. Plus 3. 1 minus 6 is a -5. Plus 8 is a 3, plus another 3 is a 6. So it has a corresponding y-coordinate of 6 that we can put down there. Right at the candidate number of x equals +1, we have the concavity changing from concave down to concave up. So x equals 1 will also be an inflection point. It has an x-coordinate of 1 and a corresponding y-coordinate that can be found by plugging the 1 back into the original function. So y equals f of 1, which is 1 to the 4th minus 6 times 1 squared minus 8 times 1 plus 3. 1 to the 4th is 1. Minus 6 times 1 squared is 1. A minus 8 times a 1 is a minus 8, and then plus 3. So a minus 6 times a 1 is a minus 6, and then minus 8, plus 3. 1 minus 6 is a -5, minus 8 is a -13, plus 3 is a -10. So it has a corresponding y-coordinate of -10. So we have two intervals of concave up, one interval of concave down, and two inflection points, one at -1, 6, the other one at +1, -10.